All right, we are on Unit 2, Lesson 2, Patterns with More Than One Variable. So how do we use more than one variable to represent a pattern? Well, recall from last lesson we learned about some properties. A plus 0 equals A. Well, what that means is we can substitute any number for A, add 0 to it, and it will equal itself. Likewise, if we multiply any number times 1, it will also equal itself. Sometimes we will need more than one variable to represent a property. For instance, the commutative property of addition. This is the property that allows us to move numbers around when we add them. So let's look at an example. 5 plus 6. Well, we know that equals 11. But what if we move the numbers around? What if we say 6 plus 5? Well, that also equals 11. So the commutative property for addition just simply means we can move numbers around, they can commute, and it will equal the same answer. When we add fractions, we do need a common denominator. So let's give this one a try. A common denominator would be 6. So the first part of this equation, 1/2 would equal 3/6. 1/3 would equal 2/6. If we add those together, we get 5/6. Well, let's give it a try in reverse order. 1/3 again equals 2/6. And 1/2 equals 3/6. Does 2/6 plus 3/6 equal 5/6? Well, yes, it does. So this will work for any numbers. Whole numbers, fractions, decimals, it doesn't, even negative numbers, it doesn't matter as long as we are adding them together. Let's write a general statement for the commutative property. Here's our 3 examples from the last page. Let's substitute the variable a for the first number in our addition problem. And then let's substitute b for the second number in our addition problem. So we could say for the first one, 5 equals a and 6 equals b. We also know from the previous page that 6, which equals b, also is equal, when added to 5, or a, will come up with the same answer. So a general statement is something that uses variables to represent a pattern we see. Our pattern is, even when we move numbers, as long as we're adding them, they will equal each other. We can test out our general statement by replacing the variables with some number. So I'm going to assign the value of 1 to a, and I'm going to assign the value of 2 to b. So let's use this and plug this into our statement as 1 plus 2 equal 2 plus 1. It is a true statement. So this will work for any variable. What if we have a negative number? What if I say a equals -1 and b equals -2? Let's see if that changes things. -1 plus -2 equals -2 plus -1. Well, I know that a -1 plus a -2 is a -3. On this side, I have a -2 plus a -1. Well, that also equals a -3. So in fact, the rule still works even for negatives. The only stipulation is that we add. What if we have more than 2 variables? Will it still work? Well, let's give it a try. Here we have 4 plus 2 plus 1. What if we moved the 2 and the 4 and had them switch places? Will it still equal the same number? Well, 4 plus 2 plus 1 equals 7. 2 plus 4 plus 1 also equals 7. So even with 3 variables, it still works, this commutative property. Again, we can write a general statement by just substituting letters for numbers. So for the 4, we could put an X, for the 2, we could put a Y, and for the 1, we could put a Z. Then just like in our original problem, we could flip-flop the X and Y, and we know it will equal the same thing. If we want to test it, we just simply assign values to x, y, and z. All right, now we've looked at the commutative property for addition, but what about the other operations? Does this work for every operation? Well, again, when we add 6 plus 3 equals 9 and 3 plus 6 equals 9, so we know this is a true statement. What about subtraction? 6 minus 3 is 3. 3 minus 6. So 3 minus 6, I know, is a negative 3 because I'm moving backwards. 3 does not equal negative 3. So this is not a true statement, which means the commutative property does not work for subtraction. All right, how about multiplication? 6 times 3. Well, we know that's 18. Well, what about 3 times 6? That also equals 18. 18 does equal 18, and this is a true statement. That means the commutative property also works for multiplication. If we were worried that it might possibly change, we could try out several variables. So we could say 2 times 4 times 2. Will that equal 4 times 2 times 2? Well, let's try it. 2 times 4 is 8. 8 times 2 is 16. 4 times 2 is 8. 8 times 2 is 16. So even with more than 2 variables, the commutative property for multiplication is true. All right, well, how about division? 6 divided by 3, well, we know that's 2. But 3 divided by 6, well, I could almost think of this like a fraction. 3 over 6, I know that equals 1/2 or 5/10. Those do not equal each other. That means this is not a true statement, and the commutative property does not work for division. So again, commutative property, or moving around of the digits, works for addition and multiplication, but not for subtraction and division. All right, now your turn to practice. Activity 1 on your worksheet. Number 1 gives you 3 statements. You must add 3 digits together. And then on the other side of the equal sign, the same digits are used, but they're in a different order. You need to write a general statement about these addition problems. The easiest thing to do is to assign value to each digit. So let's look at 4. I need to use A, B, and C because that's what my instructions say. So I'm going to go ahead and say A equals 4. B, I'm going to assign the value of 7. And C, I'm going to assign the value of 5. Now I'm going to rewrite this first statement using the ABC format. So A plus B plus C equals, well, 5 equals C, so I'm going to put C next. 7 equals B, so that's going to come next. And 4 equals A. So my general statement for the first one is A plus B plus C equals C plus B plus A. You can test this out with the other two to see if it is a good general statement. The next step is to check your statement. So assign yourself some values for A, B, and C. They can be whatever you choose. Then plug those values in from your general statement and see if the statement is true. You need to finish 2 and 3. 2, notice, uses multiplication. 3 uses some negative numbers. If it's helpful, you might want to put parentheses around the negative numbers so that you remember you are adding. For all 3 of these, the variables are given to you, so make sure you use the right ones. Also, check your statements with values for each variable. Complete this and hand it in.